All right. So right here, we have radius of convergence, radius, and then over here they ask for the interval. So this is the one that's a little harder because you got to test the endpoints. So let's do this one. Well, let's do two of them. We got a bunch of time today. Let's do these two, I guess. Yeah. So let's start with, I don't know what number this is, but here we go. Exam 4 review, part 2. Example something. Let me write it down, then we'll switch over. Find the series radius of convergence. Okay. So we're doing power series. We talked about how this, you have to use either ratio or root for the most part. Okay, so which one do you think would be better here? Yeah, I think both would maybe work. But do you see which one would be better? Or can you tell?
It could be.
So you see these little powers, right? N power, 6 to the n. That's kind of a hint that root test is going to be better because the root will cancel those. So do the limit as n goes to infinity of the nth root of base of n, which is the same as saying the limit as n goes to infinity of x minus 4 to the n over n squared 6 to the n to the 1 over n. You put the absolute value outside if you want. Try to get that out of the glare. Okay, so 1 over n is going to cancel with these powers, but this one is going to stay. So put the 1 over n on each one of those. So we're going to get x minus 4 to the n over n, because you multiply them, over n to the 2 over n times 6 to the n over n. And then that will become x minus 4 over n to the 2 over n, 6 to the first.
Okay.
Right.
Oh yeah, because we divide n over n. Okay.
So this part's pretty good already. Actually, give me 1 second. Let you write that for a moment. Okay. So this guy is going to go to 1 right here because the power 2 to the n will go to 0. So anything to the 0 will be 1. There's a proof that shows that, but we're going to save some time here. That's going to be, well, let's go ahead and take the limit. This will end up being 1 times 6. And for this to converge, it must be less than 1, right?
Mhm.
So now we remove the absolute values, which creates this range of values here. Multiply all 3 sides by 6. Add 4 to all 3 sides. So there is the interval of convergence. They only asked for the radius. So what is the radius here?
4. I mean, -4.
Let's see.
I'm
What's the
sorry.
distance from here to here is 12, right?
Uh-huh.
So halfway would be 6.
6.
So this is all they wanted for this question, technically. If they would have said interval, then you got to test the 10 and -2, which we'll do in the next example. Any questions on this?
Where you get the, in the second, the -2 smaller than x, where you get that 10 from?
This one?
Yes,
Oh, you do +4, +4, +4.
okay.
Because I need to solve for x. So I got to do it to all 3 sides.
Okay.
What did you plot in on n to the 2 over n
Mhm.
on the last part of the limit where you got 1?
This guy?
Yeah.
What about it?
What did you plug in for n?
So n is going to infinity. So basically picture this, this going to end up being a 0 up here. Right, because it's 2 over n. So this part goes to 0. So no matter what, this will end up going to 1.
Oh,
That
okay.
does that make
Yeah.
sense?
Yeah.
So even though n is going to infinity, this will eventually go to 0. So whatever this is to the 0 is 1. This is a proof that proves this, is what I was saying earlier, but I'm not going to go there.
No, yeah, you're good. I was just confused because 2 over n is gonna be 0, and then the nth term I just didn't know why it was 1, but we're good.
Make sense now?
Yeah.
Okay, cool. Okay, so let's do the next one here. I'll use the ratio just to change it up a bit. This one wants the interval of convergence. Oh no, wait a bit.
Okay.
Oh, sorry. Let's go to the next one. So here it says find the interval. So it'll be almost the exact same thing, except you gotta test the endpoints. So find the interval of convergence for the series. Where is it? Okay. N equals 0 to infinity of x minus 4 to the n over n to the 4th times 2 to the n. So the an that we're going to be dealing with is this guy. For the ratio test, what's up?
The -4 is supposed to be -2. I think you get mixed up.
Oh, yeah, yeah. Making a new question. For the ratio test, is the an plus 1 on top or bottom? I forget. I asked you that, guys, last time. Do you remember?
It was on top, I believe.
Yeah. Okay, cool. All right, so here it is, and then we'll divide them. So we gotta do the limit as n goes to infinity of oh, 1 second. So that would be, I'm gonna skip the fraction step. Oh, that's cool. So that'll be x minus 2 to the n plus 1 over n plus 1 to the 4th, 2 to the n plus 1 times divided by that guy, so it'll be n to the 4, 2 to the n over x minus 2 to the n, right? So let's break stuff up. So that'd be x minus 2 to the n times x minus 2 over n plus 1 to the fourth. 2 to the n times 2, just breaking it up a little further for you guys. N to the fourth times 2 to the n over x minus 2 to the n. So these will cancel. This will cancel. So now I have the limit m to the fourth times x minus 2 over n plus 1 to the fourth. Okay, here, let me see. Times 2, right? Got all the terms. So if I take the limit, you agree that these will go to 1, right? Do you see that? Because these are the same degree.
Mhm.
So it'll be 1 over 1. If you distribute all these terms, I can have a bunch of terms, but the first term will be n to the fourth, right? So n to the fourth over n to the fourth, the rest doesn't matter. It should be just this. This is what I'm seeing. Let me double check. Yeah, it's gonna be that.
Is that expression absolute values?
Yes.
Okay. It's not one after the less than symbol.
This is the one, yeah.
Oh, it's a one. Okay, I thought it was.
Yeah, this is supposed to be, this is the one right here. Because this must be less than 1 in order to converge, right? The limit must be less than 1. So remove the absolute values and you're gonna get -1 less than x minus 2 over 2 less than 1. Multiplying by 2 everywhere gives you a -2 less than x minus 2, 2. Add 2 everywhere and you get 0, 4. So this is the interval, but we need to test the 0 and the 4 because I need to decide, do I put an equal to or leave it as less than? All right, so on the next page, we will test the endpoints. No, I'll wait a second. You guys have any questions on this part so far?
Okay,
Alrighty. So I gotta write down the original. So the next step is plug in the endpoints. X equals 0 and X equals 4, and then determine if the series converges at, or I'll just say converges there. Here's the original. You're gonna plug in 0 for the X. Which gives you this guy. I don't know why I put X there. Sorry. All right, so we're gonna get -2 to the n over n to the 4th 2 to the n. Which will be you can separate this as -1 to the n times 2 to the n, right? And just get rid of it.
Is this a continuation of the previous?
Yeah, we're not done yet.
Oh, okay.
We gotta check the endpoint 0 and the endpoint 4. So this is 0. So I forgot to write the summation there. Okay, so these will cancel, leaving me with the series -1 to the n to the 4. All right. So if you use the absolute, the ratio test, actually, no, root will be better. If you use the root test, then take the absolute value of a sub n. And if it converges, that means it converges absolutely, right? So Ran would be the absolute value of -1 to the n over n to the 4. So that gets rid of the alternating piece. So now we have the limit of 1 over n to the 4th to the 1 over n, right?
mhm.
Oh, you know what? Root is not going to work. This limit is equal to 1, isn't it? Yeah. I should have just used the p series. My bad. Ratio, the root test is inconclusive. This needs to be less than 1, right? So I don't think this tells us anything. That was a waste of time. But we can always do this. AN, absolute
Man.
value of
I
AN.
don't know what I missed.
What's up? Okay. Absolute value will be this guy here and to the 4th. Right. Which will give me 1 over n to the 4th. So the absolute value of the series will be equal to the absolute, will be equal to this guy, right? Which is a convergent P series because P is greater than 1. So we are good at 0. So now we got to test 4. Any questions on what we just did? So what we just showed is that we can include a line underneath here, the final
Mhm.
answer, which we'll do at the end. Now we got to check the 4. So if I let x be 4, you're going to get 4 minus 2 to the n over n to the 4, 2 to the n, right? Which will be equal to into this, right?
Yes.
These cancel again. It ends up giving us the same deal. This is another convergent P series because P is greater than 1. So therefore, the interval of convergence is 0 less than or equal to x less than or equal to 4. So we're good at the endpoints and all everywhere in between. Okay, so if they ask for the interval, you got to test those endpoints. So basically, you testing one endpoint creates like a new problem, kind of.
Professor, on this, on the test for these type of problems, do we have to state the statement that you're putting at the end of every problem?
Yeah, you need to give me the justification, like why does it converge? Like everything we're doing is to justify, right?
Mhm.
And then you gotta state what test did you use and why? Why did it converge or why did it diverge? And just refer to the test and the requirement.
All right.
Okay, sir.
All right, so let me show you the answers here. So see how the answer, I mean, yeah, you can kind of choose the answer right away, but you need to justify why 0 and 4 are cool. Like if you get halfway and give me the interval, but not test the endpoints, and you probably only get about half credit or so, right? Same on this one, all they wanted was radius, so you didn't have to check. You just need to check how big that interval was. I think we got 6 as well. Okay, does that make sense?
Mhm.
So that's gonna be the same deal, do ratio. And then, what's it called? Find out where it converges and diverges and check the interval. So let's move on to Taylor. These are a little longer. The last 3 are Taylor and Maclaurin types. Okay. All right, let's do the e to the negative x. That'll be our last one, I guess. Find the Maclaurin series. Maclaurin meaning it's centered at 0 instead of some other number. So the first thing we have to do is take a bunch of derivatives, right? So first derivative is -6 e -6x. Second derivative would be 36 e -6x, right?
Mhm.
Third derivative. 6 times 36, what is that gonna be?
6 times 36. Just to 16.
Negative though, right? So it looks like powers of 6 and alternating signs, right?
Mhm.
And then it says at 0, so plug in the 0. So it's gonna be 36. -216, I think, right? So we said.
Yes.
Okay, so there's our zeros. Now we need to find the pattern. Let me get the the formula actually, because I don't have it in front of me. Taylor formula. Okay. So the formula is going to be a pattern. Ouch. So here is the formula for the Taylor series. F of c times x minus c to the n over n factorial. So we're going to get, our first number was 1, right? So that's our f, the n part, f minus 0 to the 0 plus -6 times x minus 0 to the 1 over 0 factorial, 1 factorial plus
Is that a C or a 6?
6, -6. Oh, where exactly? I'm sorry. This is a formula. This is C.
Oh, it's a C. Okay, that was ours.
Okay. So our C is 0 in this case. So we expand it and then try to create a formula for this representation here. So our formula is going to be, so we have an alternating part, right? And of course, we got the factorial on the bottom. So that's the easy part, right? So it starts as positive, negative. So what should be the power of my -1 to create the alternating?
Square.
Right. The first one needs to be positive, right? So is it going to be n or n plus 1 or 2n? Remember I gave you that list of the different types? Or just a regular n? Do you remember?
Was
Can you tell, well, when you look at the pattern, what do you think it should be?
It would be just in.
Yeah. Because if it's 0, it's a 1. If it's 1, it's minus. If it's 2, it's positive. If it's odd, negative. So just n will take care of it. Now the x part will simply be to the n, right? Although I forgot the 6, let's do that first because it looks better. 6, 0, 6, 1, 6, 2, 6, 3, 6 to the n, x to the n. That should take care of the whole thing. So this is my Maclaurin series for e to the -6x. Any questions on this problem?
No, sir.
All right, well, I guess that's it for the review. This forgot what date I told you, but let me see. Officially is 22nd. I'm gonna, you know what, I'm gonna leave it open a little longer.
Okay,
But I recommend you get it done sooner, but I mean, just in case some of you want to work during Thanksgiving, I'll give you that opportunity. So I'm gonna close it on December 2nd. And at that point, it's gotta be done.
okay.
All right, but if you want to do it early, I recommend it. Go for it.
What was gonna be closed on December 2nd? The test?
Yeah, I'll leave it open a little longer for you guys, if just in case.
What about the final?
Final, well, the final's gonna be, hold on a second. I know this, I mean, and I know this chapter can be hard for some people, so it's no big deal. So now, man, it was yesterday. Let's see. Officially, the finals week is December 6th, I believe it starts. Let me check my calendar.
Do we have to take that in person?
Technically, yes, but